Okay, thank you everybody for coming along. My name's Gary Tyne. I'm the engineering manager for arms reliability in Europe, and what I'm going to do today is talk to you about one of the applications that we've been rolling out with several organisations, and the title of the presentation is called How Vulnerable Are Your Assets? A little bit about arms reliability, not too much detail at this stage. We are a global organisation, and I'm based in the UK, working out of our European headquarters in Huddersfield, and we've been in business since about 1995. I spent 5 years in the Australian business, and we set up in the UK 2 years ago. We do have quite a broad reliability offering within the industry. The general, in reliability, the world of reliability, there are a number of different tools and techniques available, and it's really having an understanding of where we apply those tools, and a lot of them are made up of 3, 4, 5 letter acronyms. As you can see a few on the screen. What we're going to be doing today is really talking about the VAA approach, the vulnerability assessment approach, as one of the tools that we work with. But please, if you do have any interest in any of the others, feel free to come and have a chat, and we can talk to you about some of the other tools. So what is it? What is vulnerability assessment and analysis? What I would like to do is just play a very short video clip for you to watch. It's not too long, but I'd just like you to watch this video from 2012. A facility in Mexico. People working, going day to day. You see the people working down, looks like some sort of compressor station down at the front of the video clip. A car entering site, and then an explosion takes place. You can see the people down at the front on their hands and knees. This is the same explosion from a different angle on the facility. You see people running for their lives. A pretty horrendous event, as you can imagine. 33 people, I believe, were killed and numerous people injured in this event. This video clip is available online for people to see. So vulnerability, not all vulnerabilities within your facility are going to lead to something so catastrophic. But what is the definition of a vulnerability? We call it a piece out of place. Something within the facility is not right. And we tend to live with those vulnerabilities, or the vulnerabilities get forgotten about, and we're moving on to the next big thing. When there's a piece out of place and it's a single piece, often it's easy to manage, easy to deal with, and we can put in some sort of mitigation, some sort of action to overcome that vulnerability. What happens when we've got many pieces out of place? What happens when we've got numerous vulnerabilities around the facility? How do we start to manage those vulnerabilities that could come back and hurt us in a serious way? So the process that we've adopted within ARMS and working with some global organisations is It's a facilitated assessment. It can be a production line, it can be one piece of equipment, it can be the whole factory. It doesn't really matter where the process is adopted, but it's allowing us to identify and quantify the risks or the vulnerabilities within the organisation. If anybody's familiar with HAZOP studies, adoptability studies, I know many years ago I was quite heavily involved within an old role of mine within ICI, and HAZOP is a structured approach. This is a similar style approach to a HAZOP. It is a high-level study. It's done at a high level, and we're taking it as a team-based approach. We will use data to support the study, but it's based on the experience, the knowledge and the perceptions of the people who are maintaining and operating your facilities. Quite often I come across operators who have been reporting what I'm calling a vulnerability for a number of years, and their reporting of that vulnerability has not actually been actioned upon. And when you start to look at that vulnerability, we can actually quantify the production losses that they've experienced, and actions and mitigation hasn't been taken against those vulnerabilities. So it's listening to the people who are at the coalface, the people who are maintaining and operating the equipment. I'm hoping this is my only busy slide. I don't like to have too much detail on slides, but this one is really showing the process flow. And we start with identifying the scope and the boundary. What is it we're really wanting to address? Like I said, it may be one single production line, it may be a single piece of equipment, or it could be the whole facility. Once we've identified the boundary, then we've got to look at calibrating a risk matrix. Now this is just a standard 4x4. Some companies already have a risk matrix in place, maybe a 5x5, 6x6, and they will have values, they'll have impact values, and they will have likelihood values on there as well. We do the same thing, and we will use your risk matrix if you've got one. Once we work through the production line or the process flow, it's at that point where we start to identify vulnerabilities, and I'll show you the categories that we look at shortly. But the output of that particular risk assessment is a prioritization. We're able to prioritize those vulnerabilities. Now the things that fall into the red areas are the priority ones. We've got the priority twos and the priority threes. The priority ones, you will set your time limit on action implementation. So we don't identify solutions, we're not at the stage of identifying solutions, we are putting in mitigating actions. So it may result in further work, maybe a reliability study, root cause analysis, design review. There may be other things that we need to go away and do. But as engineers, we like to solve problems and fix things quickly. This is not about solving the problem. This is about putting in a mitigating task to actually resolve that problem later down the track. So you set up a method of prioritization. Then you assign that method and that priority to a functional group or a person, and it goes into an action tracking database. And we then proceed with the mitigation and looking at those actions. And then there's a review process within there as well to ensure that the vulnerability has been eliminated. It is a team process. We're sat around a room, we are facilitating, we are encouraging openness and honesty, and we certainly get that, because we find people have got things on their chest that have really been bothering them for some time, and we're putting those pieces back into place. We call the process digging for vulnerabilities. That's really what we are doing. We are facilitating the process. We are challenging, we are asking questions. If anybody's familiar with reliability studies, within the world of reliability, we're often asking what we call the 7 questions. We're asking a few more, but we are digging deep to get those vulnerabilities onto the table and look for the tasks that we need to implement to mitigate those individual vulnerabilities. I just mentioned we have 10 questions. The categories of those questions are on the screen now. We follow the process flow. We work through each stage of the process and we start to challenge and ask questions within these 10 categories. I'm not going to go into each one of them in detail, but beneath each one of those questions is another number of questions that will support the main question at the top of the screen. But examples are workarounds. Question number 2. We're finding a lot of maybe temporary bypasses, temporary operating procedures, workarounds being implemented. Automated valves have been removed because they've been causing reliability problems, and they've now implemented a manual valve and they require an operator to go and open and close the valve every shift. It's a workaround that's being implemented, but then question 7, we're relying on a person to go and do that every single shift. So we're starting to understand, using these questions, where are the vulnerabilities currently sitting. What I would say, we can customise those. We've got one organisation that has only categorised 5 questions. We've got another organisation who's actually added in 2 more questions. Okay, but that is our basic set of 10 questions that we ask when we're looking at vulnerabilities. We walk the team through the process. We print out the plant flow diagrams. We have an A0, maybe 1 or more on the wall, and we follow the process. Oil and gas, when we're in the oil and gas industry, we're starting subsea. We're following the molecule from the wing valve at the manifold, and we're following the molecule all the way through the flow lines, the risers, into the oil rig and out to the export line. And we're marking off and we're challenging every step of the way. We're identifying vulnerabilities. The average number of vulnerabilities we're coming across is around about 300 vulnerabilities. And I'm going to show a small sample of some of the outputs that we've had on studies we've done so far. Well, this is an example that this is a dust system, dust collection system with an ID fan. And the type of questions we start to ask, there'll be an operator in the room and we're saying, what sort of issues are we experiencing? And things like on the dust collection system, the operator will suddenly turn around and say, well, 2 years ago, we just used to be doing 2 yearly dust sock replacements inside the dust collector. They used to last 2 years, and then we'd shut down for 24 hours and do a sock replacement, and we'd 200 of them to change. We're having to change them every 3 months now. What's changed? So every 3 months we're losing 24 hours of production to change these dust socks. And then somebody in the room will say, well, that's because we were having emissions out of the stack and the instruments weren't very good. And so we changed the material, and the socks get blocked a lot sooner than they used to. And so we're starting to talk about vulnerabilities and production losses as a result of some changes that have been made. So we'll capture those at that level. And then there may be, I know we've talked about fans, some of the forced draft fans. People will start to say, well, the fan keeps tripping on high vibration. So that's a vulnerability. When the fan trips, the system shuts down and production is lost. And we're able to rank that within the risk matrix on impact and likelihood. And that is captured and entered into the database as a vulnerability. Okay? And we just follow the process through the system, capturing those vulnerabilities. It can be applied, the methodology can be applied to any type of process. An example there, we've got bags of crisps. Yeah, we follow the potato. Yeah, through the production line. The potatoes come into the front end of the factory, they get washed, and then they're sent through and they come out as a bag of crisps. Yeah, what vulnerabilities lie along that production line, and why are we not achieving our maximum production targets? The oil, I've already mentioned, we follow the molecule right through from the drilling, through the flow lines, up to the oil rig, through to the export line, identifying vulnerabilities. And then similar on a cigarette manufacturer, the tobacco comes in at one end, goes out as a cigarette in a packet at the other end. We're not achieving production targets. And what we find is we're not, within the facilitation, there will be often what we call the golden nugget. Something will come out that we hadn't got captured anywhere else. But more often than not, people know what the vulnerabilities are, yes? But they're working in pockets around the facility, and people will have reported things, reported issues, and they've not been acted upon because they haven't been given the risk ranking that they require. This is a photograph from one of the recent studies. It was actually overseas. It was one that I'd facilitated, it was only 2 months ago. You can see the plant flow diagrams, and you can see what we call the wall of vulnerabilities. We actually, the process, we've adopted our own individual post-its, and that's where we're actually capturing the system, the equipment. Some of the vulnerabilities will go down to the tag level, you will go down to the maintainable item. Some of them may be system vulnerabilities. Some of them we end up calling them generic. It could be something that's applicable across the facility. So it varies at what level we actually go down to and where we report the vulnerability. But that's the output. These vulnerabilities don't stay on a piece of brown paper. We take them off, we enter them into some VAA software, and the outputs and the graphs and the reports are produced from the vulnerability software that we're actually using. This is the fear that we're often faced with from the management team. And it's, well, we're already busy, we've already got lots of work, we've got lots of actions in other systems. This is really going to just create a lot more work for me as a manager. But what we're able to do is show the prioritization and the cost benefit of mitigating the risks and the vulnerabilities that have been identified. And as I said, we do the prioritization, we're looking at that likelihood, the impact, and the cost benefit. We will capture the safety risks and any environmental issues, but the predominant driver initially is production, and then the safety and the environment will also be identified. Which are we working on first? What number of priorities are going to fall into each of these categories? Somebody will be assigned the vulnerability mitigation task to go away and work on. I just mentioned the software. We do capture the data, we take the post-its, and we'll have one of our reliability engineers during the study will be entering it into the software, and by the end of the week we're able to actually present the results back. So we don't leave site and disappear for a few weeks. On the Friday, usually about lunchtime on the Friday, we're presenting the outputs back to the team, and we validate as well. You know, how does that feel when we're identifying those priority ones and we're discussing them? Does that feel right? The deliverables. With the data that we've collected, we have numerous ways of what I would call slicing and dicing the data. What do we want to see, and in what format would we like to see it? So there's an example where we've been able to do the risks, identify the vulnerabilities by systems. So this might be these might be different production lines, It might be different systems within an oil rig, for example, subsea, topsides, oil export, a number of systems. So you can look where the risks currently sit. You can look at the priority ones. Where do the big vulnerabilities currently sit? And we can understand which system we need to go and focus our effort on. And then focus and effort. I mean, this is really the graph we find that managers are really wanting to see. And it's the cumulative risk. And this is an example from a recent study where 270 vulnerabilities were identified, and 24 of them accounted for 95% of the risk. So where am I as a manager going to focus my effort? On 24 vulnerabilities that have been identified. And if I don't look at any of the other vulnerabilities and I just focus on these initially, that's really where I'd be putting my effort. This is another way of taking the data out. This particular output was carried out on a single piece of equipment. It wasn't a small piece of equipment, it was quite a large asset with lots of functions, functional failures and failure mechanisms. It had been proven to be a production stopper within a facility, and they wanted to present it, they wanted it to look almost like a safety triangle, and they had 33 out of 108 vulnerabilities that were identified that could result in a significant outage to their business. You can see their risk matrix. It was a 4x4, and 2 vulnerabilities fell into the devastating impact and very high likelihood, less than 6 months. So we are working through the process, identifying the vulnerabilities, capturing them, and then prioritising them. So that's the presentation, the vulnerability analysis presentation. Just to summarise, we have been in business since '95, been active in the UK and Europe for the last 2 years. There are a number of different tools and techniques available in the marketplace. Please, we've got the stand over to the side there. If you want to talk about any of the others, we are available. Vulnerability analysis, we've said it's identifying the pieces that are out of place. Where are they? We have 10 questions, 10 standard questions. We can customise them. They don't need to be the standard set, okay? I had a lady speak to me a few weeks ago, and we're seeing it more and more, obsolescence of spare parts. Now one of the questions is about critical spares. We also talk about maintainability, but this particular organisation want a question about obsolescence. That's fine. Let's put one of those questions in there. And let's follow the process. Follow the process flow. It's a team effort. You've got the maintainers, the operators, maybe some other engineers. Follow the process flow and let's identify them on that journey. And then ultimately it is about prioritising and focusing the effort that we need to put in place. Thank you very much. Thank you.